Okay, so this kind of grew out of, well, partly a talk I'm giving for the Wakefield RISC-OS club next month, and some stuff Dave was on about last time we met about how you kind of reskin games. But for those who don't know, this is a VideoNuLA. Has anyone seen them before? So I've got a couple here that I've made this week. Just to give an overview for those who sort of have not come across it before, essentially it replaces the VideoULA in the Beeb or Master or whatever to give a 12-bit palette. That was my kind of original goal, giving 16 solid colors in mode 2. So this started in about 2016 for me. Started thinking about doing this. Having developed that, some people in the forum said, oh, what about horizontal scrolling? I added that in, and then I think Rich Talbot Watkins started talking about attribute mode, so I added those in, at which point the CPLD, which is nowhere near the size of the one on Ed and Rich's board, was completely full, or so I thought. I'll come back to that. But if you want to sort of like play with one without actually having the board, B2 is the emulator to go to. It has kind of the most complete emulation, although it's not 100% complete, as I found out in preparing this talk. I'll come back to that later. So if you're used to sort of programming the standard ULA at a hardware level, you'll know it has two registers, FE20 for control, FE21 for the palette. NuLA gives you two extra registers, and they sort of mirror these. There's an extra register FE22, which controls the NuLA, and an extra register FE23 for the NuLA palette. And if I get the board again, there is, I've got to use this because it's mirrored. There is a little fly lead that comes off the side to pick up that extra address line. And it has to be two extra registers because although on the Beeb, I think there are 8 addresses that are mapped to the VideoULA, on the Master is only 4. So you can only have 4 registers in that space. In terms of programming the palette, on the Beeb, the way it usually works is you have logical colors numbered 0 to 15 or 0 to F in hex, and then you map those using the ULA palette at FE21 to physical colors. So if you've ever done like VDU19 on the Beeb, that's what you're doing. You're mapping logical colors to physical colors. What the NuLA adds is extra NuLA colors via this extra palette register at FE23 that maps the physical colors into these sort of RGB, 12-bit colors, whatever you want to call them. We call them NuLA colors there. But so the way it works is that there's a 4-bit index for 0 to 15, and then 4 bits for each of red, green, and blue. So that's 2 bytes. So the first write sets the index and the red component. The second write sets green and blue components. So for instance, if you want to change physical color 7 to orange, we poke the NuLA palette register with 7 for the index, F, which is full red, and then the second write 6 for kind of a midway green, and 0 for no blue. So to program a color, it's 2 loads and 2 stores. I'll just, if I come out of this and if I can find it, I'll just go to B2. Can you guys see that? Can you see in B2?
Yes.
Yeah. Okay, great. So just to show you that, I'm not used to using this actually. I tend to use BBEM, but it doesn't have the emulation. So again, as I said, the first write, I'm mapping physical color 7, which if you know your Beeb colors is white. Setting the red component to F, which is full red, and then second one, so mid blue and mid green, no blue, and there you go. You get orange, and I can just show you. So that's how you do it at a hardware level. There is, if I go recent disk image, where are we? Is it on there? Yeah. Oops. No, it was always, I forget that it freezes when it changes disk. Let's try that. There is a palette utility. It comes with a ROM and there's a palette utility. So just forget that. So the sort of things you can do, you know, it's pretty obvious, but you can change the shades, get, you know, whatever colors you like, really. Okay, I'll go back to the slides. Okay, so let me just go make sure. Yeah. So one of the things that, you know, this sort of grew up with Dave talking about how you reskin games. So what you want to do really is, because you've got 16 colors available now in mode 2 rather than sort of 8 plus the 8 flashing on the Babe, you want to sort of modify games to use the extra colors. And what I found when I was starting to look at this was a tool on the retrospect site called GFX RIP, and that was, I think, for like Amiga, ST, maybe the Amstrad as well. I can't quite remember, but it was designed so that you could like hunt for graphics or sprites in executables, and I modified that to understand the Babe screen modes and the way that the colors are defined in sort of bytes. And yeah, as it says there, you know, you can find sprites, rip them out, and then modify them to use the extra colors, and then re-import them, and you get sort of, you know, the sprites with the new colors. And what you would do then is, as I've said there, set the palette in either loader or find some space if you can in the game code. I know Dave Foot did Jetpack recently. I'll show that in a minute. And he kind of went through and found some space to set up the NuLA palette, and they changed all the sprites to use 16 colors. If you haven't seen that, I'll set that up in a minute. I did a couple of games a few years ago, Daredevil Dennis and Hunchback. If I share again. Okay, and drive note. Let's have a look at this. Yeah, so we'll go for Daredevil Dennis. I'll run it first, and then just turn that off. Can you still hear me?
Sure.
Right. Oh, sorry. So what I've done is, oh, actually, so having said that, I've one thing you can do is, I should have reset it from the my messing around before. You can reset the thing. Just reset that. That looks better. So what I've done is just change some of the sprites. You can see the browns and the oranges and the greys. I'll just dying when he, it's a little flame when he dies. So the way I did this, if I just so I can find this here for you guys. Here we go. Give me a second. This this GFX RIP application isn't the sort of best behaved application to run. It was a bit of a quick hack on my part. Let's see if I can we can share that. Quite sure it's picking up. I'll have to share the desktop. Oh, there we go. Yep. So what you do with this is there's a bit of a clunky interface, but you load in a binary, and what I'm going to do just for this is I'm just going to load in the SSD file actually, which is a bit of a cheat. You shouldn't really do this, but it does work. So I'll just find it if I can. Unfortunately, it tends to be right. So if I find Daredevil Dennis, there we go. So this is what you're presented with. Can everyone see that? Yeah. What happens is usually when it comes up, it's displaying things in 1 bit per pixel, and then you can just tell it to go into 2 and then 4 bits per pixel. And so that's equivalent mode 2. And what you then have to do is you have to kind of find these sprites. Now you can see, if you look at the sort of right-hand side, there are some sprites showing up. But what you need to do is get the right size. So you can change the grid size. And I happen to know, because I've done this before, that the Daredevil Dennis sprites are 8x pixels wide and 16 y pixels high. So if I just move things along a bit, you should see the window at the bottom right. That gives you a little sort of like magnified view. There we go, there's the first sprite. And then we can cycle through them. And we can see that we've got some sprites. And there are, because I've done this before, there are 28 of them. I go back to where they start. And what you can do with this routine is you can save the sprites out. So I can save the pictures. I can tell it that there are 28 sprites running in X direction, and they're all in one row. So there's none, don't want to save anything in the Y direction, and they're running left to right rather than up to down. And they can save those out then as a bitmap file. I'll call it Dennis. Okay. Come out to that. And no, it's, yeah, that's fine. What you can do then is, if I just, let's have a look. Wait a second. Here we go. We'll just share the folder. What we should have in here is a bitmap. And if I'll just open that up and hopefully I'll just share my screen. Can you see that? So what we have saved out there, before I wreck it, are the bitmaps. And what you can do now is you can edit those. So at the moment, what they're doing is using the kind of 8 standard solid colors in mode 2. There are some flashing colors actually. You can see these gray eyes in this skull, and in the lighthouse that they're using flashing colors, but you can change those. So what you can do is you modify this to use 16 colors. And if I hopefully, let's not do it from there. If I should have it in here. I forgot what it's called. And yeah. Okay. What I did was, as you can see here, so I've modified the sprites to use the extra colors. So for instance, this color here, this sort of mid-yellow color, is defined to be orange, well, in the loader, similarly with his hair. And then the tree, which is this kind of dark magenta color, is defined to be brown. So it's his shoes on the boat. And so what you can do is rip out the sprites, extend them to use 16 colors, and then re-import that back into the binary, or in my case, the SSD file. And what you effectively done is reskinned the game to use 16 colors. So that was Daredevil Dennis. I'm just going to show you a little trick. So this is Hunchback, which was actually the first game I ever got for the Beeb. sort of the January after I got my beep for Christmas. If anyone's played it, this is what it looks like. It looks pretty, well, pretty terrible in some ways. The colors are pretty garish. But one of the things it does, and one of the tricks you can use with BM, if you go to the debugger and you do rvidproc, it tells you how the palette is set up. So you'll see here, it shows you how the colors are set up, but actually the way the palette works in mode 2 is that the values are exclusive ordered with 7. So what it's saying here is that logical color 0 is physical color 0, logical color 1 is physical color 1, and then so on and so forth up to 7. And then the flashing colors are actually being redefined to map down to the solid colors. I'm not quite sure why, but that presents a problem for us. If I come out to this and go back to here, what that means is if you look at the way Hunchback is done, we have the logical colors being mapped to physical colors, so note 7, but then the flashing colors 8 to 15 also being mapped to the physical colors 0 to 7. And because of the way that VideoNuLA works, in that it maps the physical colors to the RGB colors, you would find that the red, which has been mapped to gray, both reds go to gray. So rather than getting 16 colors, we're still confined to 8, which is a problem for us because we would like 16 colors. And lots of games use tricks like this. So for instance, Firetrack, if you ever looked at Firetrack, that has essentially 3 foreground colors and 4 background colors. And it does that. It maps the palettes so that when you exclusive or sprite plotting, you don't get color clash. Some games map the palette because they want to use the flashing colors to signify sort of special platform or whatever for collision detection. And then some games, like I think Pole Position, they use the flashing colors and map the palette for animation, like sort of animating the red and white sort of stripes at the back, the sides of the track. So this gives us a problem, really, thinking of like Hunchback particularly here, because we want to use 16 colors and we can't because the game author has mapped the logical colors to the same physical colors. But fortunately, VideoNuLA has a useful trick for this. What you can do, you can put in a mode that maps logical colors directly to the RGB NuLA colors. So it basically bypasses the VideoNuLA palette at FE21. So it just completely ignores it. And that means that whatever the game author or the original author has done, you can just say, oh, forget about that. And we'll get complete control over the palette. So the way this works is, as I say, instead of mapping the physical colors to the NuLA colors, it maps the logical colors to the NuLA colors. And there's a simple poke to put into this logical mode. Say bypasses the NuLA palette. One side effect of this, and to be honest, when I put it in, it was kind of like, oh, that might be useful. And I didn't really think why or what it could be used for. Obviously, it's useful if you want to do this kind of trick. But also, if you want to do like a split mode, so if you had like a mode 2 at the top of the screen and mode 1 at the bottom, say, but the problem when you're doing that is that you have to, on a standard beep, you have to reprogram the palette, the ULA palette at FE21, because they're programmed differently for different modes. And that's actually quite expensive. So you can't do a kind of a really quick split between, say, mode 2 and mode 1. You have to kind of blank out a few lines, which is annoying. But with this, because I'll show the way it works in a minute, because you're bypassing that and the NuLA palette can remain the same for both modes, effectively you can do mode splits, not just sort of vertically and sort of pretty much instantaneously, but also horizontally. I've got a demo somewhere, I couldn't find it in time, unfortunately, but I did write a demo a few years ago, which actually did a mode split with mode 1 on the left of the screen and mode 2 on the right. But it's kind of a useful trick anyway. I'll just demo that. So what we do here is if I go into mode 1 and just put it into the logical mode, you'll see it goes a bit mad because it doesn't know how to interpret the palette. Oh, actually, let me try that again. Sorry. Oh. Just reset it. Make sure I'm typing in correctly. Which I'm not. Right. Let's try mode 2. Not quite sure why it's not behaving as I expect it to. Not sure about that. I was expecting that the color to change. What should happen, and it does work in B2. I'm not sure why it's got itself in this position, but what it should do is it should change from white in mode 1, which is logical color 3 but physical color 7, to yellow, which is physical color 3. Not quite sure why I didn't do that, but I might try and revisit that later. But it does work. So if we go back, right. So the other thing it does, apart from programming the palette, is that it does horizontal scrolling. So if a standard Beeb in any mode, what you have via the 6845, the CRTC chip, is single byte scrolling. So if you look at the memory map, this is mode 4, but it's the same in all modes really. What you can do is advance the screen memory pointer by 8. And that means you can shift horizontally by 1 byte. What NuLA does is that in any mode, it allows single bit scrolling. So in mode 4, where there are 8 pixels per byte, that's single pixel scrolling. In mode 1 and 5, that's half pixel scrolling. And in mode 2, it's 1/4 pixel scrolling. Although, his question was as to kind of how useful that is, but certainly for games. But you certainly get single pixel scrolling in any mode. The way this works is that there's a scroll offset. So again, you poke the control register FE22 with 2 in the upper nibble, and the lower nibble has an offset between 0 and 7. And it just tells you how many bits to scroll to the right. The other thing you can do, which I'll demonstrate in a minute, is blank out the left-hand side columns. So you poke the control register with 3 in the upper nibble and value between 0 and 15 in the lower nibble, and that blanks out however many bytes you specified. So again, in mode 4 or mode 0, that would be 8 pixels. And in mode 1 and 5, 4, and mode 2, 2 pixels times whatever you set the value to. I'll try and hopefully this demo will go a bit better than the last one. So I'll just reset it just in case. What I should have perhaps done is I'll go to mode 4. I'll first of all show the blanking. So what you do is there we go. What I've done there is I've told it to blank off 1 byte's worth of left-hand column. So actually I haven't done anything with screen memory. This isn't the same as reducing the screen size with a CRTC. As far as the 6845 is concerned, it's still a 40 character mode. What we've done, but you can see that the left-hand border, if you like, has moved across 8 pixels. And then what you can do with this offset, if I just set it to 7 to begin with. It shifts everything back across 7 pixels. I don't think B2 quite gets this right because it's put the cursor in the wrong position, but and then what you can do is if you want to scroll left, say, or move the screen to the left, you can gradually, pixel by pixel, scroll the screen. And what's happening is, obviously the data, the sort of pixels that you would ordinarily see as the whole screen is shifted to the left, is effectively moving the screen, is hidden behind that blanked out column. So it gives the impression that the screen is slowly being scrolled, and I can keep doing that. And then so the idea with this is that this is scrolling, as I say, sort of a bit at a time rather than the CRT scrolling, which is a byte. But once you come to the end of this, if I go right across, if I can type on this thing, if I come right across, you get to this sort of position, and then one more, and that's right across then. What you would then do is, once you've kind of moved across as far as you can, you would then push it back out. So we would push this back out, and then use the CRT scrolling to move on 1 byte. So in this way, what you can do is just have this sort of very smooth scrolling rather than the kind of coarse scrolling you ordinarily get, certainly in mode 0, mode 4, perhaps mode 1 and mode 5. And it's very cheap, obviously, because it's done in hardware. What I'm going to do now is just reset it and just show you a little demo. So that's reset everything. You can see that left-hand column's reappeared. And I've got here something I knocked up last night. He says, yeah. So this is using the CRTC scrolling. It's a bit of a contrived example, to be honest, because you could do better than this on a Beeb, on a stock Beeb. What I'm doing is I'm scrolling this little map with some tiles, and I'm scrolling it every 8th frame. I'm scrolling it by a byte, so 8 pixels. So it judders a bit, but it kind of works. And you notice you could hide this a bit better than I have, to be honest. But what I'm doing is I'm deliberately doing the update in that left-hand column, so you see the kind of tearing that's happening there. There you go. And I'll just show you the code for that, and we'll go through. And I'll just show how you adapt that for the NuLA. So if I can, this is just some BBASM code. What I've done initially was set NuLA to false. I'll just set NuLA to true, and we'll rebuild in a minute. So what I'm doing is I've got some various 0 page locations set up, but it goes into mode 4. It's a 16-row display. I've changed VSync just to move it down. For NuLA, what I'm doing is blanking off some columns. I'm going to be blanking off some columns on the left-hand side. I wasn't doing that initially. I've got some variables initially, just a map and screen pointers. What I'm doing is, you sort of followed Kieran's masterclass on interrupts. I'm just enabling the VSync interrupt, and then I've got my own IRQ routine. The main body of the routine just copies the tile data to the screen in that left-hand column, as you can see. So I say it's very simple. And I've got upper and lower tiles just because I converted the map from on some MSX site that happened to produce data in that format. So I come down a bit. Right, this is the interesting bit. What I'm going to be doing, what I've got is on the IRQ routine, I've got a little counter that just increments, decrements every frame. So it's kind of a NuLA scroll offset. And so the version we saw earlier wasn't using that, but we'll use it in a minute. And then what happens is every 8th frame, the CRTC scrolling comes in. So there's a little thing here that compares it to 20 and says, oh, if you're doing that, then we do a CRTC scroll as well. So that's what that does. There we go. And that's just setting the CRTC registers to do the CRTC scroll. If you've got NuLA defined, what we do as well is every frame, we set the NuLA scroll offset using this NuLA scroll value. And then, yeah, just comes up the interrupt. So I'll just rebuild that to show you the difference. If I can just share that. Okay, let's have a look. Doesn't seem to want to. Oh, there we go. Back to that. So what I've done now is just rebuilt that disk image. He says, yep. This time we're using the NuLA scroll. It's a bit jerky on here, actually. I think there's something, but you can see now, rather than the sort of shifting by 8 pixels every 8th frame, it's 1 pixel per frame. You get a very sort of smooth scroll. And it's say, although it's a slightly contrived example, it was actually quite simple to adapt that to do the NuLA scrolling. You essentially just get the NuLA to scroll every frame, and then when you get to 8, you get the CRTC scrolling to take over. So it's pretty straightforward. Okay. So the last thing, I'll try and be quick here as well, is attribute modes. And what these do is, as found on like Spectrum, MSX, Commodore 64, lots of 8-bit micros, what you have is, alongside the pixel data, you have like these attribute bytes that tell it things like what color the foreground should be, what color the background should be for that block. Beeb doesn't have an attribute mode, and therefore doesn't suffer from the kind of dreaded color clash you get on like a Spectrum game or whatever. But as I say, when I was developing VideoNuLA, it was kind of suggested that maybe we should have some attribute modes. And there are 2 types. So you have attribute mode that reduces pixel resolution, and attribute modes that reduce color resolution. I'll just talk about those a little bit. So the first ones I put in were these reduced pixel resolution modes. So say rather than kind of 640 pixels in mode 0, you get 480 horizontal pixels. And then what you do is you use the extra bytes that you've kind of lopped off, 160 of them, to or extra bits really, to store the attributes. And again, there's one for mode equivalent for mode 0, there's an equivalent for mode 1 that rather than having 320 pixels has 240. Again, this is not the same as reducing the screen size using the CRTC. What you're doing is those 240 pixels or 480 pixels will stretch right across the screen. But the lost bits, so 2 bits in every byte, are used to give you extra colors. So for instance, the 480 by 256 mode has 4 blocks of 2 colors. So rather than the just standard 2 colors in mode 0, you can have effectively each 6 pixels can have their own choice of 4 palettes. And similarly in the 240 by 256 mode, rather than 4 colors in mode 1, each block of 3 pixels now, rather than 4 pixels, can have a choice of 4 colors from 4 blocks. So effectively, you can display 16 colors on screen. Obviously, there are some restrictions. In terms of reduced color resolution attribute modes, there are 2. One is a ZX Spectrum mode that I added just for the ZX Spectrum emulator, really. It's actually a little bit better than the Spectrum does, because the Spectrum has attribute mode that has attributes that affect 8 by 8 pixel blocks. What this mode does is affect an 8 by 1 pixel block, and you can set the foreground color, background color, flashing and brightness for that 8 by 1 pixel block. And also there's a Thomson MO6 mode, I call it, mainly because I got hold of a Thomson MO6 at the time. And what that does, I think it's very similar to I think MSX might do it, and I think the Enterprise Alan does it. What you can do within a block of 8 by 1 pixels, you can choose the foreground and background colors from any one of 16, and obviously those 16 on the NuLA can be chosen from a part of 4096. The way this works, the reason this works is because effectively the Beeb's video memory bandwidth is twice what these machines are, or almost twice, in that you can interleave bytes. So the Beeb can send an attribute byte followed by a pixel byte, then attribute byte followed by a pixel byte. Whereas these machines are doing some resolutions of about, well, mode 1 resolution. Obviously the Beeb can do the mode 0 resolution. So effectively what you do, you put the machine in mode 0, and then the NuLA interprets every other byte as an attribute byte. So you still get the 320 pixel resolution horizontally, but you get greater choice of colors. So for instance, you can have, as I say, 16 colors for the foreground, 16 colors for the background in any 8 by 1 block. The way you do this is, again, right to the control register. You set the upper nibble to 6 to enable the attribute mode. 1 for the reduced pixels mode, the 240 or 480 horizontal resolution. 2 for the spectrum mode. 3 for the MO6 mode. And to disable, you just set to 0. The VideoNuLA ROM has extra modes built in. So for instance, you can do mode 97, which is a 240 by 256 mode with 16 colors, essentially, although there are some limitations on because of their attributes rather than sort of giving you free reign. But they are built in, and there are also some, I haven't covered them here because they're not really as sort of relevant to games programming, but there are some text modes that take it a little bit further by making use of the gap between letters. I'll just quickly demo the attribute mode. Unfortunately, and I only found this out when I was doing that, preparing this. It's gone way off. B2 only implements the or emulates the 240 and 480 modes. It doesn't emulate the Spectrum or Thomson modes yet. I didn't realize that actually. Can I do it? Where am I? Recent disk image. Here we go. I'll get used to it one day. This is just a quick example. I'll go through the code once. What this is doing, I mean, it doesn't look much, and some of that you can see, but what this is a 480 by 256 mode. If I do a listing, let's see a bit more. What you've actually got here is it's allowing you to have for every 2 colors from a choice of 4 blocks. So the blocks are defined. I'll go through the code in a minute. The blocks are defined as background of black, foreground of blue, background of black, foreground of yellow, background of black, foreground of green, and background of black, foreground of red. And what you're seeing here is effectively when I'm doing the MOS is listing out the program, and it's in this mode, the VideoNuLA is interpreting some of the bytes from the characters as attributes. So that's why you get this kind of funny colored text. Obviously the MOS doesn't understand it, but the VideoNuLA ROM can, and so that can, it will sort of get things to work properly. And there's a font built into the ROM that is narrower, so you can still get your 80 characters or your 40 characters, even though the pixel resolution is reduced. I'll just show what it's doing. It's not particularly complicated. What we do is we set the palette up. Basically, you define the ULA palette as you would program it for mode 2. As I said earlier, the ULA palette is programmed differently for different modes. In these attribute modes, you program the palette as you would for mode 2. And what I've done here is just set pairs of colors. This is covered in some more detail in the manual, but you set pairs of colors. So as I said, background of black, foreground of blue, background of black, foreground of green, so yellow, background of black, foreground of green, background of black, foreground of red. And then what I'm doing is, if you look at line 140, I'm just writing some bytes to the screen. This is all written so it'll work on a CoPro, that's why it's kind of a bit convoluted. But writing FF, FE, FD, and FC, what you're doing there is you're writing a solid line, and then the last two bits in the byte define which of the palettes to choose, or the blocks of colors to choose, and that's why you get those 4 colored blocks at the top of the screen, because it then knows that I'm solid line for, and the attribute is blue, or the blue palette, the solid line, and then the yellow palette, and the green, and then the red. I think that's about it. Let me just check. Yeah, that's the end. Sorry, that was a bit of a rush through at the end, but any questions?
Rob, how many colors can you get in the text mode for the 80 column text mode?
Yeah, so there's an extra. We haven't talked about this because it's kind of more kind of I guess use kind of for serious applications. But there's an 80 column mode. It's 480 pixels, but it uses a narrow font in the ROM, and that because it makes use of the gaps between letters, can actually give you 8 colors. There are some restrictions on how those colors are used, but in a text mode, that's not perhaps as relevant. But I've had things like view sheet and view working with that. You know, it's all kind of legal stuff, so it intercepts the VDU driver and kind of does its own stuff, but it works with legal software. And as I say, you get 8 colors in, well, 80 column mode. I think there's probably a video on YouTube of me demonstrating that. You can also get, there's a 16 color sort of 40 column mode. Again, there are some restrictions because these attribute modes, as you know, that's on the spectrum. You get some restrictions on where you can place the colors, but you know, that works pretty well. If you're doing text, if I quite like it, on the font's a narrow font, I think it looks quite attractive.
Thanks. That sounds interesting. I thought it might be interesting for syntax highlighting for code and stuff. Might be
yeah,
useful.
I think someone was going to use it to kind of sort of like a kind of terminal emulator. And I think that was before I did. They wanted an 80 column mode where you had kind of, you know, 16 foreground colors, 16 background colors, which you couldn't quite do at the time. But now with the extra modes that are in there, the Spectrum and Thompson mode, you know, if you did a really narrow font, you could get 80 columns, and you know, you could do a pretty good, you know, like sort of Linux terminal kind of thing.
Or if you want 80 columns for your text adventure.
Yeah, absolutely. Yeah. One thing I didn't do actually, if I stop sharing this, I'll show you, just to kind of highlight the point really. If I can find it. If I list this, if I do a kind of quick draw, if I can type, what happens is you notice that the mouse still carries on and kind of draws the diagonal line, but of course what's happening is every byte, the last 2 bits have been interpreted as attributes, which is why you get those nasty gaps. But it doesn't quite get it right, but it sort of works.
Do you want to finish with your Shadow of the Beast demo, or do you want to show that as well as any more questions?
Yes, I can find it. Yeah, why not?
It's a shame not to in this company.
Yeah. This I wrote this when I was on holiday. It was a bit of like, oh, let's see if I can do this. Finding it might be fun actually. Let's have a look.
Can I just ask a quick question while you
do that. Well, I'll try and find it at the same time.
It's along these lines with the narrow font. So the font would be 6x8 instead of 8x8.
That's right. Yeah, that's it. Yeah.
I was just wondering if there's a mode that you could do a nice ANSI. I'd be quite interested in writing like a an ANSI
Yeah,
screen.
terminal kind of things, means it?
Yeah. The other thing is in mode 0, I think it's 32 lines high by 80 across. Would there be a way of making it so like ANSI mode is 25 lines of 30, so you're saving
Yeah, you can. Well, you can do that with the CRTC will do that for you.
Well, it's mode
Right.
3, isn't it?
Yeah, exactly. Yeah.
I was just thinking about the memory that you save to be used as attributes in a full 80 column. I mean, it'd probably be a different hardware.
Yeah, what you'd probably want to do is you'd probably right. Let me just you'd probably want to think about master just to make sure I've got this uses sideways RAM image just to store the code because it uses all the screen memory. It wouldn't on a master. You wouldn't need to do it like this on a master, but it's designed for the Beeb. You need a ROM image to store the code. So what this is doing is using the smooth horizontal scrolling. So if you look at the clouds, I don't quite sort of flicker in there. If you look at the clouds in the background, the ones that are farthest away, they are scrolling at 1/4 of a pixel time. And then the next ones up are like 1/2 a pixel, then a single pixel, and then 2 pixels. And similarly here, I think this bit's scrolling at single pixel. And this might be this 2 and this might be 4. I can't quite remember. But this is using vertical rupture, and it essentially uses all the screen memory because for each block, each 8 row of 8 pixels vertically, it uses 2 copies because like a ribbon that just rolls around and it's vertical rupture. So what I'm doing is each block, I'm updating the CRTC scrolling and the NuLA scrolling. And then there's also a palette change around here, which to give, I think there are about 64 colors on screen. So I think there's one palette here and separate one here, and then the green and then the brown. So that that would be right. 4 palette changes for 64 colors or thereabouts.
I was just thinking, Rob, I remember showing some of your stuff basically in about the video anyway, because I got it in my machines.
Yeah.
I forget what show I was at. It might have been Cambridge or something. And basically the fact you could change the palettes. And then somebody said to me, oh, well, doesn't that change what the Beeb is? And I was just like, well, what are you getting at? Oh, well, it's not pure then, is it?
Yeah, I mean,
what are you talking about, man? And I thought,
yeah.
well, have you had any of that?
Yeah, a bit. I mean, I got some people sort of saying things like, it's not a Beeb, which is fair enough. I mean, but that's what it's a hard upgrade. I mean, the reason it started was because there was I saw an advert in an old Acorn user. I got a load of Acorn users from a guy in Cardiff. Just went round there and picked them up because he was getting rid of them. And I was flicking through them one night and saw this advert for the Palette Mate, which was made by a company called Wild Vision, who did a lot of Archimedes stuff. And this was in about 1986, so just pre-master.
Is that the thing that went through the user port? Did it?
No. I'm not quite sure how it worked, to be honest. I'm not quite sure whether it replaced the ULA or whether it intercepted the RGB out and then stood between that and the monitor. But it gave you 16 solid colors in mode 2 and a part of 4096 colors. And I really thought, I wish I'd known about this. I would have had a BBC B at the time. And thought, I really would have, if I'd known about this, I would have probably bought one. They're about 69, 70 quid, something like that, I think. And I really thought, well, I looked on eBay for ages for one, thinking one will turn up, looking inside machines. You think, has anyone got something looks a bit odd inside there? And it never turned up. And then eventually I kind of bit the bullet and thought I'll have to make it myself. One thing I was going to do actually, just to show, when people say, oh, it's not a Beeb, is it? I have some sympathy with that. I mean, I don't know if how many of you have seen this, but I'll just share this. Let's have a look. I'm just going to share this. briefly. This is Jetpack that Dave Foote did. I mean, he's on the loading screen and stuff. I don't know if he doesn't. I'm rubbish at this anyway. I can't play it. But what it makes me think, that doesn't look like a Beeb game to me. So you know, they've redone all the sprites. They put 16 colors in. He kind of a bit like the sort of reskinning thing I was talking about. You know, I'm dreadful at this. Is fun. I put the font in just because I thought the only reason you could tell it was a Beeb game, apart from the Mode 7 sort of intro screen, the high score table, whatever, was because of the Mode 2 font. But I just think, you know, yeah, it is still a Beeb underneath. You know, you're still a 6502 machine.
Oh yeah, I mean,
I think it feels like a logical extension to me.
Don't get me wrong. I mean, as you know, I'm a huge supporter of this project and what you've done. So I buy it very much in the idea of, well, if you're going to keep these Beebs running in the 21st century, they need new bits to make them interesting and ready. You're either preserving it as a museum piece,
yeah,
or you're adding to it to make it something interesting that means it's worth its keep. You know, like the one.
Yeah, I mean,
so yeah, that's my feelings on it. But
yeah, I mean, I've heard. I mean, initially it was purely because I thought I would have liked one of those back in the day, and you know, couldn't get hold of one, so it was a purely sort of selfish thing. I think I want one, so I'll have to make it. And
then you made it, and then I wanted one, and then
yeah, well, you know, lots of people have got them now.
Yeah,
and you know, so yeah, I take the point. I mean, it's not a pure Beeb anymore, but then, you know, I guess how far back do you kind of draw that? I mean, it's not like the upgrade wasn't available back in the day. So it's like a ROM board or, you know, a Shadow RAM board or, you know, the upgrade was there. So, you know, you could have done it back in 1986.
Well, was it 82, I think, the first palette extender, wasn't it?
Yeah, I think that's right. Yeah, I mean, yeah, that's right. And I mean, that, because I've got Phil's board here, that gave you, I should have brought it down. That gave you kind of, you know, power 4096 colors. You could really find any of the 8 solid colors. You know, so these things were available, you know, and I think there were several of them. You know, there was the palette, there was a Saturn board, there was obviously the Cluid board. I think there was another one as well I've heard of. So that, you know, that they were around. So yes, okay, it's not a pure Beeb anymore, but it's not like, you know, they weren't there.